Hi, and here we have on this first slide of 8.1 and 8.2 a little ACT review. If you look at question number 1, it gives you a table and it says which equation relates the variables correctly. So we're basically looking at a way to write that equation in slope-intercept form from a table. Well, the first thing that I notice is that right here, when the year is 0, the money saved is 4. That tells me my y-intercept is 4, which means my answer either has to be letter C or letter D. So I know right away I can eliminate those 3 options. Well, if I look at what my slope is going to be my change in y over my change in x. So that would be 20 minus 4 over 2 minus 0. Well, 20 minus 4 is 16. 16 divided by 2 is 8, which means 8y plus 4. Again, looking at number 2, the equation of the line passing through 2 points. First thing I notice is I have an ordered pair 0, 3, which means my y-intercept has to be 3. So I know I can eliminate h and I can eliminate k. And from there I just need to figure out what my slope is. Well, again, that's change in y, so that'd be 3 minus 5 over 0 minus negative 3. So 3 minus 5 is negative 2. 0 minus negative 3 is 0 plus 3, which is 3. So I know my slope is negative 2/3, which is letter G. And the slope of a line on question 3, the slope of the line parallel to that line, I'm going to throw it into slope-intercept form. So I'm going to subtract 3x from both sides, and I would get 4y equals negative 3x minus 12. If I divide everything on both sides by 4. My slope of my line is negative 3/4. Well, if it's parallel, the slopes are the same, so negative 3/4 is letter A. And then on question number 4, again, you just have a table, and it's wanting you to write an equation and then use that equation to figure out what the value would be when after 10 years. So if we look, I know my y-intercept is going to be 4. My slope, if I figure that out, I'm going to have 20 minus 4 over 2 minus 0. 20 minus 4 is 16. 16 divided by 2 is 8. So my equation is y equals 8x plus 4. Okay, and it wants to know after 10 years, so I'm going to say y is going to be worth 8 times 10 plus 4. That's 80 plus 4, which would be 84,000. Okay, so now actually getting into the chapter material. We have chapter 8, section 1 and 2. There's going to be several videos that go along with this. Just some vocabulary that goes along with it here. So we have sequences and series that can be finite or infinite. So a sequence is basically just an ordered list of numbers. Okay, so let's get that in there. It's an ordered list of numbers. Okay, a finite sequence has an end. Okay, it's a limited number of terms. Okay, that's what finite means. Infinite means that it basically continues without end. Without end. Okay, if we are looking at a finite sequence, that would be something like 2, 4, 6, 8, 10, and it stops. Okay, we're only talking about the first 5 terms. If we're talking about an infinite sequence, that means it would be like 2, 4, 6, 8, and it would have these dots at the end indicating that it goes on and on and on. When we talk about the terms in a sequence, okay, so like if we are looking at a finite sequence, okay, let's kind of separate some stuff here. Okay, let's say the terms in our sequence are what we have up here. So our terms are going to be 2, 4, 6, 8, 10, and then we don't know where our sequence ends, but it'll end at the nth term. The domain is what term it is in the sequence. So 2 in this case, the domain is going to be 2 is the first term, 4 is the second term, 6 is the third term, 8 is the fourth term, 10 is the fifth term, n is the nth term. Okay. The range is just a little bit of notation about it, is going to be a sub whatever the domain is. So for the first term, it's a sub 1, 4 is going to be a sub 2, 6 is going to be a sub 3 because it's the third term, 8 is going to be a sub 4, a sub 5, and then the nth term that we don't know is going to be a sub n. So that's just a little bit of vocabulary that we're going to be using in this chapter, actually these first couple of sections. So if we are looking at sequences, okay, an arithmetic versus a geometric sequence, basically an arithmetic means it has a constant first difference. So that means it has a constant first difference. So for instance, in the series, or excuse me, not the series, the sequence 2, again, I'm just going to use this one because it's easy, 4, 6, 8. If you notice the first difference here from 2 to 4, it goes up 2. From 4 to 6, it goes up 2. From 6 to 8, it goes up 2. So your first difference is 2, and it's constant every time, which means that's an arithmetic sequence. If you had, I mean, it can go different ways. So if you had some negative numbers like -9, -2, 5, 12, okay, to go from -9 to -2, that's +7, +7, +7. So your first difference in that one is +7 because it's going up. If it happened to be going down, it would be negative. In a geometric sequence, it has a constant ratio. Oops. So for instance, if we had 2, 4, 8, 16, 32, okay, to find our ratio, we basically divide 2 of the terms in our sequence. So 4 divided by 2, this is like times 2, times 2, times 2, times 2, which means it's geometric because it's being multiplied by something each time. And it can go the other way. So for instance, 9,